This conference will now be recorded.
Now let us find the Fourier transform of x of t, which is equal to a complex exponential signal plus or minus j omega naught t. From that, let us calculate the Fourier transform of cos omega naught t and sin omega naught t. In first case, the Fourier transform of a DC signal which is equal to 1. It is already we have seen that 2 pi del of omega. Now we have the frequency shifting property of the Fourier transform. It says that if x of t, Fourier transform x of omega, then e to the power of minus j omega naught t x of t Fourier transform. It should be x of omega plus omega naught. So here if x of t is equal to 1, then e power minus j omega naught t Fourier transform, it is 2 pi del of omega with omega replacing with omega plus omega naught. So the Fourier transform of e to the power of minus j omega naught t, it is 2 pi del of omega plus omega naught. Similarly, we can find the Fourier transform of e to the power of plus j omega naught t. It is 2 pi del of omega minus omega naught. So from these two equations, we can calculate the Fourier transform of the cos omega naught t signal. That is, we know that cos omega naught t is equal to 1 by 2 e to the power of j omega naught t plus 1 by 2 e to the power of minus j omega naught t. So let us apply the Fourier transform on both sides. So Fourier transform on both sides of this expression, that is Fourier transform of cos omega naught t, it is equal to Fourier transform of 1 by 2 e to the power of j omega naught t plus Fourier transform of 1 by 2 e to the power of minus j omega naught t. So from the above equations, it is 1 by 2 exponential Fourier transform, it is 2 pi del of omega minus omega naught plus, for the second term, it is 1 by 2 Fourier transform, it is 2 pi del of omega plus omega naught. So that 2 cancels. We have pi in common, taking outside of the expression, that is del of omega minus omega naught plus del of omega plus omega naught. So the Fourier transform of cos omega naught t is equal to pi del of omega minus omega naught plus pi del of omega plus omega naught. Similarly, we can find the Fourier transform of Sin omega naught t, that is equal to Fourier transform of 1 by 2j e power j omega naught t minus Fourier transform of 1 by 2j e to the power of minus j omega naught t, so that it is 1 by 2j Fourier transform of exponential, it is 2 pi del of omega minus omega naught minus 1 by 2j 2 pi del of omega plus omega naught, so that 2 gets cancelled. So in both the terms we have pi by j common, so take it outside of the expression. This pi by j del of omega minus omega naught minus del of omega plus omega naught. This should be the Fourier transform of sin omega naught t.